Sachin Agarwal is a solution architect at Nirmata. So he has designed solutions for large-scale monitoring and orchestrating cloud-native solutions, and he has played a vital role in fostering cloud-native concepts and microservice architecture in teams and community. Anudeep Nalla, DevOps engineer at Nirmata. So he's an open source contributor specializing in Kubernetes, Kyverno, and automation. His main focus is on optimizing DevOps workflows, security, and compliance. I'll invite them onto the stage.
Thank you so much, Anand, for this warm welcome.
A little introduction on the talk. So the talk is about managing cost effectively. This has become like a critical focus for organization. So in this session, Sachin and Anudeep will walk us through an easy to adopt and intuitive solution that leverages Kyverno policies and simplify and automative resource management in Kubernetes environments. Thank you, and over to you.
Thank you, Anand. Hi everyone. As Anand has already introduced us, so I'm working as a senior solutions architect for Nirmata. So before I start, I just wanted to tap on like how many of you know Kyverno or have worked with Kyverno here? Quite a bit. Okay, fine. So to start with, this is the agenda for the today's talk, where we'll just tap on what is Kyverno and what are the capabilities. Then we'll also talk about a basic of how to write a Kyverno policy so that you will understand what is the structure of a policy. And then we'll talk about the advanced use case of how you can author any policy which can monitor your costing and also the resource efficiency. And we'll talk about the reference architecture, like how you can design it for your environment. And then we'll have a working demo also prepared for you to understand how this whole thing works. Okay. So what is Kyverno? So Kyverno is a CNCF incubating project. We are the, Nirmata is the main creator of Kyverno, and we have donated Kyverno to CNCF back in 2013. So Kyverno is a Greek word for govern, and that's what the whole idea about Kyverno project is. So it's a cloud native policy engine, right? And it works on the admission control and other webhooks that are implemented in the control plane at Kubernetes level, right? So since Kyverno is native to Kubernetes, so there's no new programming language that you have to learn, because it's all work on YAML construct or JSON construct, so it is easier to understand and write, right? So there are different type of policies that can be implemented using Kyverno. So few of the examples, like you can use validation policies which can validate your data. It can also mutate any resource inside Kubernetes on the runtime and even validate that. You can even generate certain configurations based on certain events inside Kubernetes, and you can write the cleanup policies. You can even write policies for verifying your images, whether it is coming from the trusted source or not, right? And then recently we have also added a support for the VAP using cell expression, because if you see in the current trend, cell expression is something which is getting more popularized, and it is also much faster as compared to any other regular expression or any other logical expressions that you write inside Kubernetes, right? So there's a different topic on how cell is being introduced and how it is being leveraged in Kyverno, but definitely you can give it a shot and see it on the documentation. So this is a architecture of Kyverno and how it works. So as you can see here, the whole Kyverno system actually taps on the API request path, where you will have a authentication, authorization, and then it comes with the three type of webhooks that is implemented on the admission control, which is mutating admission, then the schema validation, and then the validating admission, right? So that's where Kyverno is being implemented. It doesn't come in your data path. It only comes in the path when the API request is being made to create any resource or update any resource inside Kubernetes, right? It has multiple components in it. As you can see, it has a reports controller, it has a background controller, then we have a admission controller. So reports controller is basically to generate the resources against whatever policies that you have defined and the outcome of it. whereas the background controller is used to scan through your resources in the background and apply those policies which you have defined. And then we have all the other components and the main engine which is used for applying those policies on your resource, right? So what are the capabilities of Kyverno? As I mentioned, like it is it is easy to use. You can definitely go and write your Kyverno policies with a simple YAML construct. We also have a Kyverno CLI which can help you out in testing all the policies that you are authoring right before deploying it in your Kubernetes environment. So you can even write a unit test for your policies using chainsaw tests, right? So chainsaw is one of the projects that we have created to write a unit test for your Kyverno policies. Auditing and reporting capabilities are there in Kyverno, which can help you out in aggregating all the policy reports and the findings that are being done based on the policies that you have written. So as I mentioned, like validating, mutating, generating, and cleanup and image verifications are a couple of common examples where these policies are being written, and now we are expanding it beyond Kubernetes and we are taking it for other JSON data also that you can validate using Kyverno, right? So we have a very vast library of policies. It's around 500 plus policies that you will readily find on the open source repository. So I would suggest you to just have a look on those policies, and definitely it might cover a couple of use cases that you might face in your environment, right? So it's a best starter for applying these policies and then playing around with the Kyverno. And then, as I mentioned, we are taking this beyond Kubernetes, and you'll see that now it is Kyverno JSON policies that are getting more traction, and we are actually using those policies to validate any JSON data. So even if you can think of validating any resource that is being created inside cloud, you can even validate those using Kyverno policies, Kyverno JSON policies. So this is a bit about Kyverno and what are the capabilities. Let's now just deep dive into how you can, a novice person can write an policy or author a policy. So this is a typical structure of Kyverno policy where you will see that there is a rule, right? And inside rule you will have two sections, which is one is the match section, which actually matches for your resource that you want to apply policy on, right? You can even define the exclude function, which can filter out your resources based on certain conditions, right? And then we have a second section which defines what kind of a validation you want to do. Do you want to validate your resource? You want to mutate your resource, generate your resource, or you want to verify an image? So based on that, you can define a policy as it is mentioned on the left side. So we have a cluster policy which says that the validation failure action is enforced. So there are two categories in it. Either you can enforce. So what does enforce do is, when you have applied this policy to your Kubernetes cluster, it will not allow that resource to get created if it is failing the policy, right? So let's say if you are creating a pod with the privilege access, right? Then the policy which defines that your pod cannot run with privilege access, it will block those pods to get deployed inside Kubernetes, and it will flag off with a policy violation and a policy report saying that you can't create that resource, right? So similarly, this is one such example, which is using a validate rule to check whether the team label is present on a particular pod or not, right? So it's a simple example, but there are many more such examples you will find in the library. So now let's try to see how we can leverage Kyverno policies to understand and to build advanced use cases like resource efficiency and how can you tackle the resource wastage inside your Kubernetes environment, right? So one of the biggest problem statement that most of the organizations that they are facing is continuous right sizing of the resources. The developer teams or the DevOps teams, they tend to allocate a lot of resources to your workloads, even though those resources are not being used very efficiently, right? So resource allocation is one of the key problems that we see in a lot of organizations, that they are just over provisioning their resources and they are not using it efficiently, right? So reducing the inefficiency of resources due to the dynamic nature of Kubernetes is something that we are working on, and we are creating the solutions around it. So this solution is actually tapping into those areas and trying to trying to ease out how you can use the resource efficiency and provide valuable output from the policies, right? And the third thing is understanding the cost implications of those over utilization or over provisioning of the resources. Because when you take this solution to any upper management, the first question is like how much I'm saving out of this solution, right? So definitely you need some data to clearly visualize how much I'm going to save if I apply those configurations which are provided by the solution, right? So that's where the understanding the cost implication of the over provisioning, it becomes much more important, and how you can visualize that to the upper management, right? So how you can decrease these over provisioning and the cost implications is something which we'll talk about. The last point is defining the cost policies for the teams and budgeting, right? So a lot of times we have seen that there are multiple teams who work on a single cluster, right? And there's no such mechanism of cost budgeting on the namespace level, and you want some criteria on which you can define whether the person is able to deploy any resource inside namespace and it is not crossing any budget of which is allocated to that namespace. So that's where you can define those policies also using Kyverno and the other solutions like OpenCost and other, right? So that will help you out in creating those policies. So this is a reference architecture which is a good starter for you to start implementing these kind of policies. So what we are going to do here is we have a couple of components that works in conjunction to make this whole solution working. So we have a VPA recommender. Anybody who has heard about VPA earlier? Yeah, so vertical pod autoscaler actually has 3 components in it. One is the VPA recommender, right? The other one is VPA updater, and the third one is mutation, which actually mutate the resource, right? So VPA recommender is the model in itself which actually understand your traffic pattern and the resource utilization pattern and provide certain recommendation for your resources for your optimal resource utilization, right? So let's say if a pod is running and it is receiving a traffic, so over the time it will actually analyze your traffic pattern and the resource utilization, and based on that it will give you some certain recommendations for the optimal function of that workload. Then we have a metric server. So the metric server is the component which VPA uses to analyze those resource utilization, and based on that it gives the recommended values. And then we have a VPA configuration which is required for each resource so that whenever a new recommendation that is provided by VPA can be tagged with that particular resource, right? And then we have a policy report which will be generating the policies if any of the resource is not passing the VPA recommendation. So in this conjunction we have 2 policies here. One is check resource policy and other one is generate VPA. So when we were working on this solution, the biggest challenge was how a developer or a platform user can automatically generate these VPA configurations for all the workloads that are running inside Kubernetes, right? So the best idea is to use the Kyverno generate policy. So what it will do is the moment you are deploying any new resource, be it a deployment or a daemon set or a stateful set, an event is generated, and Kyverno can automatically generate a VPA configurations for you, right? So you don't have to generate those configurations manually, right? So that is one part which ease out the whole VPA configuration creation. And the second part is the check resource policy, which actually checks for your resource, continuously check for your VPA recommendation that is provided by VPA and how much a particular resource is being allocated to your pod, right, or your deployment. So based on that, it analyzes the VPA recommendation and it generates the policy reports against it, saying that either you are over provisioning or you are under provisioning your resources, and based on that it also gives certain suggestions like how much you should allocate. So this is one part of the solution. The other part is now to so we are generating the policy reports, but how can we automate to in a real time we can update these configurations on the pod, right? So with version 1.33 as today Crook also mentioned that with version 1.33 there is a beta feature where you can in place upgrade the resources in a pod, right? So with this solution and the beta feature that is implemented in the 1.33, you can have a in-place resource updates on the pods. So you can even update the CPU and you can even update the memory without restarting your pods, right? And that's where this whole solution become very powerful. And then you can use other solutions like KDA and Carpenter to automatically right size your worker nodes on which it is being provisioned. So this is the reference architecture on how we have implemented it. So I would like to call Anudeep so that he can show you the live working demo of this, how this whole thing works, and all the components are getting stitched together. So over to Anudeep.
Hello. Yeah. Good morning, everyone. So, okay. So, like as Sachin mentioned, like we'll be needing a VPA metric server. So also you can also install Prometheus. So like by default VPA fetches metrics from the metric server. You can also install Prometheus and you can fetch the metrics from the Prometheus as well. And like then you need Kyverno as well, which is an admission controller. And you have to deploy a couple of policies. So first we have like generate VPA policy. Okay. So here like it's a generate policy. Where we are adding like generate existing equal to 2. So what does it means is like, suppose let's say you have already deployed couple of deployments in your cluster, and this generate existing with the help of background controller will create a VPA for the existing resources as well. And like it is matching for the deployment and stateful set. And like there are two modes, audit and enforce. And the second policy is like check resource YAML, and where it is matching for the deployment stateful set and daemon set. And you can also add an exclude block where you don't want to create any VPA for a couple of the deployments or a couple of namespaces. So you can add this label or you can exclude in the namespace section. And then we are doing an API call to the VPA where it fetches the like it checks for the name, is the VPA is created or not. We are adding a preconditions, is the VPA exist or not, and then like when the VPA has been created. And then we are adding a for each loop where it fetches the CPU and memory from each and every container inside the VPA, and it saves in a variable which is counter. Okay. And then we are adding a conditions like this is a logic where it fetches for upper bound and lower bound from the VPA, and the same way like it also does it for CPU. So here I have already like installed metric server, VPA Recommender, and the Kyverno is running. So I have deployed a sample application where it has like one container. So whenever you deploy this application, the VPA will be automatically generated. So I'm just describing the VPA. So like this is coming from the metric server, like VPA fetches, VPA observes like how pod is behaving, and depending upon the metrics, it gives you recommendations. So here I have deployed a deployment with one CPU and like 1 GB of memory as a limit, and one CPU and like 200 like MB as an memory. So like this policy report is created by the check resource policy, where it says like this is a container, it has 2 failures. when you read this policy report, so here you can see in the message section, like it has over provision resource, and this is the recommendation we are getting from the VPA, and like it is saying you to like reduce CPU request from for the container name called app, because like this is a container name I have given in the deployment, and from like 1 CPU to 15 millicore. Okay, and the second thing in the same way, we have over provisioned resources for memory. For the app container, you have to reduce from 200 to 32 MI. So let's reduce the, let's apply the recommendation as suggested by the VPA. So 15 MI and 32. Like it's gonna take a minute or two. Till this apply, like till this fix, any questions till now? From the VPA. VPA gets the metrics from the metric server or the Prometheus. So metric server and like VPA itself is a VPA has a component called recommender. It analyzes the resource utilization from the metric server, and it gives you a recommended value. Like it gives you lower bound and the upper bound.
So basically, VPA Recommender has an inbuilt model that is part of the VPA Recommender section. So what it does is it takes the metrics from metric server, and you can even have a Prometheus integration so that it can take the long-term metrics to analyze it in a better way, right? So it takes that data, and based on that data, it defines the lower bound, upper bound, and the untargeted value. So there are certain cases where people don't put any limits and requests to your workload, right? It tracks that also in the section called untargeted data, right? So even it will generate the recommendations for those resources which are not created with the request and limits. So it takes that data based on the Prometheus and metric server data, and then it recommends it to the resource like on which it has to be applied, right? So that is the data which we are using, leveraging, and then evaluating whether the resource is under that particular recommended value or not. So that's how it is working. Yeah, so with the open source Kyverno, you can have a policy reporter dashboard, which can give you the view of which resource is actually failing the policy and how much is being recommended. So you can use that. For email feature, I think you have to configure it in your dashboards to provide that as an email output. Yeah, so you can definitely do it. You can have a Prometheus rules and alerts around it with the dashboard in Grafana to get all those abilities. Yes, yeah. No. So yeah, that's what. Policy reporter dashboard is there, which can give you the view of how many resources are there and what policy they are breaking. We have not integrated that here, but definitely you can give it a try. It's a policy reporter dashboard. You can search it; it will find it.
Yeah. Now you can see now both the rules are passed. Okay, and like this is how. Yeah. Is
that correct?
Yeah, the VPA configuration is created for each resource. Yeah.
So what is the for every having one?
So you have to understand it's not a workload that is running as a VPA configuration, right? It's just a configuration. So what VPA does is, VPA is a central deployment that runs, right? And it generates that configuration and put it in a for that particular resource. So it's what VPA which is running, and that's where it is going to consume the resource, not too much. So as you can see, Anudeep, if you can show the current utilization of VPA,
Okay.
It's not that heavy as compared to other sidecars that you run with your workloads. It's very lightweight, and it the only work of VPA is to generate that configuration and tie it with your workload. Yes, it exists as long as your resource is there.
Yeah, right now VPA Recommender is using like 1 millicore of CPU and like 15 MB of RAM. This is the deployment.
We have done the load test on this, and it doesn't goes beyond 100 millicores. So that's what we have seen. But if you have any data and if you have worked with large clusters, I'll definitely love to see that output.
Any more questions? It keeps on updating, like according to traffic, like according to the load, like it gets the metrics from the metric server or the Prometheus, and VPA updater will be keep on recommending like accordingly. Yeah, Kyverno policy will check, like there's a background scan, like by default, the background controller default time is 1 hour. Every 1 hour, it's keep on checking each and every resource and checks for is there any violation or not. If you want to reduce it to 1 minute or 2 minutes, it's up to you. It's configurable in the Kyverno background controller deployment. Okay. Yeah. Mm-hmm. Yeah, there's a component called VPA updater as well, but that's not recommended in production because it's update on the fly. So sometimes due to that, because VPA updater will update on the fly. So here in the policy, we are taking an average of. So here you can set a time. Like suppose let's say it analyzes the 24 hours pattern, and then it gets the recommendation using this policy. But suppose let's say if you enable VPA updater, right, it updates on the fly. So due to that, it may cause some outage or something like that.
So VPA updater actually is quite aggressive in terms of applying these patches to the resources, right? And it can cause some disruption. So the idea is to have it in a controlled way, right? So what this policy does is it applies the policies, but it start acting on that data after 24 hours, right? Because we have ample amount of data now to analyze and then start giving some recommendations, right? So what I would suggest, or what we suggest, is that instead of using the updater, you can have an integration with KDA and Prometheus, so that you can control the whole updation process, and you can even use Kyverno mutate policies to mutate those resources on the fly.
Okay. So like one thing, let's say like if we have 500 pods are running, right? So how are we gonna manage?
So you don't need to manage all those things, right? Because the policy is generic enough for all the resources. What you want to do is you want to automate the whole process of patching, right? And that's where the KDA, because as you know, KDA can take input from Prometheus also, right?
Yeah.
So once the data is generated and once you will see that there is a policy violation, it can act on those policy violation and generate a mutate the resources based on those events.
Okay. So we can add KDA, we can add Kyverno inside KDA basically. Like
So
we can do
yeah,
the
you can
integration.
integrate KDA with Kyverno because the policies that are generated is again a resource that is created inside the Kubernetes, the policy report. So based on those events, you can generate a KDA event and you can mutate the resources.
Okay. Okay.
So VPA has no impact on the HPA, because HPA is basically it horizontally scales your workloads. So let's say there's a huge load that is coming on your workload. So what it will do is it will horizontally scale based on whatever replicas that you have given, maximum replicas that you have given. right? But what if it goes beyond that, right? The load is much more than what you have added in the HPA, right? So it is at the brim of the maximum replicas that you have set, and still it is using the high CPU or low CPU, right? So in that case, how will you generate those recommendations and how will you update it, right? So that's where it works in conjunction with HPA. There is no impact of VPA on HPA, right? HPA will work in its own way, and VPA is just to give you the recommendation based on the workload or the traffic pattern that it is receiving. So it just analyzes the whole data. So since the data is there in Prometheus, it will analyze the whole time period of that data, and then it gives you the recommendation based on that, right? So it continuously changes its behavior based on the traffic pattern that you are receiving on the pod, right? So based on that, it will keep updating the recommendations also.
Okay, so let's say you have some chaining multiple policies on complex CRD. So how are you handling that?
Sorry, can you repeat?
So you have multiple chaining policies, like that is mutating the deployment or cluster. You told, right? Like we mutate the deployments and then the CPU requests and memory. So let's say we have a complex CRD, and then you want to mutate a chaining policies, like you have set up policies which is mutating that. Then how are you handling that on the backend? I mean, if it's a complex workload, and then.
So when you say complex workload, I want to understand, like, is it multiple containers?
Yeah, multiple containers, and then your mutating policy is working directly on it, without any delay, and then how are you handling the?
So one thing that we have to really make sure is that whenever you're using such kind of solutions, you should implement the graceful shutdowns with your applications. Since now with version 1.33 already you can do the in-place upgrades which doesn't require any restart on your pod level or on your container level, right? So that will be really helpful, and you don't need to restart your pods or it will cause any disruption, right? It will actually change the configuration on a fly, right? So eventually there is no impact on your workload because it is not getting restarted. But
there will be delay, right?
Yeah, definitely there will be a delay because it's a processing time, and it's also the recommendations that is generated by VPA. But it's not something like it will act upon it after 1 hour or something, right? So based on the data and how you are fine-tuning your policy, because it has that execution time, right? So you can change that time, and accordingly you can tune it according to your workloads.
So thanks.